Hi, my name is Bashi, and today I'm going to go over valid anagram. So, we're given two strings, S and T. Now we have to return true if T is an anagram of S, otherwise we return false. Now, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, okay? Typically using all the original letters exactly once. What does that mean? Well, if I have a string S, right, and I have some characters in it, I have to rearrange these characters, all these characters, to form another string, right? String T. You can see that T is just a rearrangement of string S, so we return true. That's what an anagram is, right? Just a rearrangement of letters. Let's look at example 2. We have string S and string T. Now we have rat and we have car. You can see that in this one here, we're missing the letter T, right? We had a T over here, but we don't have it over here. Instead, we got a C, right? This is not a rearrangement. T is not a rearrangement of R, right? Because if it was a rearrangement, well, then we would have something like ART or TAR, right? It doesn't matter. They just have to be a rearrangement of these letters, which T here is not. So we return false. So you might have picked up that this has the same amount of letters as this, right? This has 7. And this also has 7. They're just a rearrangement of each other. So we can say, right, at the very beginning, if S length does not match my T length, well then I return false because I'll have an extra letter somewhere, right? They have to match each other. They have to be the same length. In order for us to rearrange 7 characters, well, we have to end up with 7 characters, right? If that's not the case, if we weren't given the same length, well, we just return false, right? Now let's look at string S and string T. You can see that the letters were A, N, G, R, and M. For S, A appeared 3 times. For T, A appeared 3 times. N appeared once for S, and then T, it appeared once, right? Same thing for G. R appeared once. M appeared once, right? S matches with T, right? They have to have the same amount of characters for them to be an anagram. So one approach that you might take to solve this is count how many times these characters appeared in S and appeared in T, and then compare them, right? If they all match, well, then we have an anagram, return true. But we can actually just solve this using one single array. And this array will start at index 0, go to 1, 2, 3, 4, all the way to 25, because we need to keep track of all the characters in the alphabet, right? There's 26 characters in the alphabet, so we need 26 spaces, okay? Don't forget that we have this 0 here. That's why that's 26 spaces. Now, initially, this array has all the elements set to 0, right? 0 here, 0 here, 0 here, 0 here, all the way to space 25. They're all 0. Now, what we're going to do is that for every character that we see in S, we're going to add. And for every character that we see in T, we're going to subtract. And we're going to do this all at the same time, okay? So, for example 1, right? S was equal to A, N, A, G, R, A, M, right? And T was equal to N, A, G, A, R, A, M. Now, remember that strings are just arrays. So we're going to loop through this array, right? We're going to loop through this string. We're going to start here at the beginning of the string. We're going to work our way all the way down to the end of the length of S or the length of T, right? They should be the same length because remember up here at the very beginning, we checked that they were the same length. If they weren't, we automatically return false. So they're the same length here. So before we do this down here, I want you to know that this spot is for A, this spot is for B, this is for C, this is for D, all the way to Z. So how will we know which index to pick, right? We only have index values from 0 to 25. We don't have character values, right? We only have index values. So what character do we pick? Well, let's go up here, right? if I take an A and I minus an A, I get 0, okay? Because this is an ASCII value minus the same ASCII value, well, we get 0. Now, if we take B minus A, right? This is an ASCII value as well, but it's 1 more than A. And A here is still the same ASCII value. So whatever this ASCII value is, plus 1 minus A, well, that gives us 1. And for C, right, that's another plus 1 ASCII value minus A, well, that's 2, right? And we can repeat this all the way till we get to 25, right? For 25 would be Z. So the formula that we'll use is S of I, and I'll write I in there in a second, minus A, and T of I minus A, right? So I in here. And why is that? Well, I'm starting my loop at 0 all the way to my length of S, right? In this case, I go all the way up to 6 because I have 0, 1, 2, 3, 4, 5, and 6. Now let's go through the iterations, right? Let's start at the beginning. So at the beginning, I is 0, so I is 0. So S of 0, which is A, minus A is 0. Remember, for S we are adding, so we add 1 to 0. So this becomes 1. And for T, remember, for T we minus. For T of 0, we have an N. So wherever our N is, we minus 1, wherever the N is. So we move on to here, right? Our iteration moves to 1. So now for S, remember, we add for S. So for N, we add 1. So you can see that it'll just cancel this out and set it back to 0 for N, because we subtracted 1 here and now we're adding 1 here. Also for A, right? For A, now we subtract 1. First we added 1, now we're subtracting. So this will come back and reset to 0 as well. And we repeat this for all the iterations of S and T, right? We add for S and we subtract for T. Now, at the end, if I had 3 A's in S, I plus 3 my A's, right? But I also had to have 3 A's in T for it to be an anagram. So I had to minus 3 here. So these will cancel out. So for my A's, it should be 0. Same for any letters, right? Let's say that I had a different string, S and T. This string had, I don't know, let's say this string had 1K, and let's say it had 10 J's, right? All here. I'm not going to write it out, but let's say it was K followed by 10 J's. Well, this T needs to have 10 J's somewhere, and it also has to have at least 1K, right? So for my K's, I would have plus 1. For my J's, I would have plus 10. Now, for my T string, for my K's, I'm going to have minus 1, right? Because for T's, I minus. So this will cancel out to 0. And for my J's, if it's an anagram, I should have 10 J's in here. So this would cancel out these 10 and go back to 0, right? You can see at the very end, our array has to have all zeros in it to be an anagram. If it doesn't have all zeros, then it's not an anagram. I hope that makes sense. So I'm going to erase this here. I'm going to write this over here and erase this. I'm going to get rid of the background. I'm going to bring up my code editor and we'll go ahead and walk through the solution. Now you can see that we're given the string S and T, right? So at the very beginning, we want to make sure they're the same length. If they're not, we want to return false. So let's go ahead and write that up. If s.length does not equal t.length, well, then it can't possibly be an anagram, so let's return false. So if we get past this, we want to create this array here. So let's do that. We'll create an array of integers. I'm going to call it count. Okay, so we created an array of integers of size 26, right? 0 to 25. Now, like we did down here, we want to create a for loop, right, that iterates from 0 all the way to the length of the strings, right? So let's go ahead and write that up. So this for loop, it's going to start at 0, right? And it's going to go all the way to the length of the strings, right? It doesn't matter here if I put T or S, they should be the same length because we checked that up here, right? And every time we increment by 1. Now remember, we want to check them both at the same time, right? We don't want to make 2 for loops. We can just do it with 1 for loop. Let's just do 1 for loop, check them both at the same time. We check both string S and T at the same time. How do we do that? Well, I go to my array, right, and say that for the letter of S, right, which is, remember the formula that we wrote here, wherever I is at, right? So S of I right now is A, minus A would give us 0, right? So at location 0, go ahead and add 1, okay? So for A, we're going to use the formula and get 0. So for location 0, I'm going to add 1. Now for T, I'm going to minus 1, right? So T here, right, they're both zeros at this moment in time. T of I, right, I is 0, so T of I is N. And N minus A will give me, I believe, like either 13 or 14, I'm not too sure, but whatever that location is, I'm going to minus 1. So I'm going to be at -1 right now. Then it continues, right? I is now 1. So for N, again, we're going to get the same thing that we did for T, N minus A, so I think location 13 or 14, but instead we're going to add 1, right? Add 1. So we had -1, we're going to add 1, so it's going to be 0 at this moment in time here. Same thing for T. For T, we have A, so A minus A is 0, so we're going to minus 1 at location 0. And remember, we added 1 from S, so now we have 0, right? These cancel each other out, right? And we do that through all the length of the strings, right? We keep doing that. At the very end, if it's an anagram, the array should contain all zeros. So let's go ahead and check. So I'm going to say for each int, and I'll call this total, in count, we have to check it, right? So it's going to loop through all the array, right? And it's going to call it total. It's going to say for each total here, for each total here, total here, total here, all the way to index 25 for this total here, right? If that total does not equal 0, well, then that means we don't have an anagram, right? We return false. If we exit this for each loop, that means that everything was 0. So we have a valid anagram, so we just return true. And this is the whole code right here. I'll go ahead and leave it up for a second so you guys can look at it. I'm going to go ahead and take it, copy it. I'm going to bring back LeetCode. I'm going to get rid of this here. Now we did it in C#, so let's go ahead and paste it in. Run it, make sure we didn't make any syntax errors. All right, and let's go ahead and submit. All right, you can see that we passed all cases. Now let's do the same for Python. I'm going to come up here, go to Python. I'm going to go ahead and just paste it in. Now you can see that it checks the strings, make sure they're the same length. If they're not, it automatically returns false. Then we create an array of 26 all set to 0, right? And it goes from 0 all the way to the length of S, right? Either S or T, it doesn't matter. They should be the same length, right? We do the same thing. For whatever letter we saw, we go to the corresponding index of that letter and we add 1, right? And that's for S. For string T, we do the same thing, but we minus it, okay? Then after that, everything should have a total of 0. So we say for every total in count, if the total is not 0, return false. If we get out of this for loop, that means everything was 0, so we'll return true. Now let's go ahead and run it. Make sure we didn't get any syntax errors for this either. Okay, now let's go ahead and submit. All right, looks like we passed all cases for this one as well. And that concludes my explanation on valid anagram. If you found the video helpful, go ahead and give it a thumbs up. If you have any questions, comments, or suggestions, go ahead and leave a comment down below. Consider subscribing. I'll be putting out more videos. And that's it. Thank you for your time.